Alright, this video is going to show you how you can write the equations of circles in the coordinate plane and how you can use those equations to identify some interesting facts about your circle. Alright, first things first, the formula that you need to know in order to be able to write the equation of a circle is given below. It says x minus h quantity squared plus y minus k quantity squared equals r squared. And this is for when the circle has its center at the point whose coordinates are hk and with a radius of length r. Now, that said, you do need to memorize this formula. So once again, let's take another look at it. X minus h, the whole quantity squared, plus y minus k, the whole quantity squared, is equal to the square of the radius. And again, this is for a circle whose center is at the point whose coordinates are hk and whose radius is of length r. Now, like anything else in math, sometimes this looks a little bit more complex than it really truly is. So let's go take a look at some examples of how this would, or how these equations would be written, and at no time at all you're going to be writing them yourselves. So the directions for the next few say write equations for each of the circles given below. And in part A, they tell us that they want our center to be at the point whose coordinates are 3, 6, and they want our radius to be of length 10. So my general formula is x minus h, the whole quantity squared, plus y minus k, the entire quantity squared, is equal to the square of the radius. So my h value here would be 3, my k value would be 6, and my r value would be 10. And now it's not anything more fancy or more complicated or more sophisticated than simply substituting into the formula. X minus 3, the whole quantity squared, plus y minus 6, the entire quantity squared, equals 10 squared. I'm going to leave the left-hand side of this equation alone, and I'll talk a little bit more about why and how come in just a minute. But I'm going to simplify the right side of that equation. Instead of writing 10 squared, I'm going to make that 100. That is my answer. This is going to bother some of you at first because you're not going to feel comfortable leaving it in that form. The reason that we're going to leave it in that form is we can see pretty clearly from here that this circle has its center at the point whose coordinates are 3, 6. This circle has a radius that's equal to 100, or I'm sorry, 10. If we FOIL these out, it's going to be a lot less clear exactly what the center of our circle is and what its radius is. Some of you are going to say, but wait a minute, Mrs. McCann, that equation still has both x's and y's in it. I don't like the look of that, and I don't like the feel of that. And I'm going to tell you that when you write the equation of a line, y equals 2x minus 3, that equation still has an x in it, still has a y in it. Your circle behaves no differently. When you write the equation of a parabola, y equals 2x squared minus 3x plus 5. This equation also still has x's in it, still has y's in it. The circle is no different. Even when all is said and done and it is finished, it still contains an x, still contains a y. So that might feel a little bit uncomfortable at first, but the more you do it, the more you get used to it, the more comfortable you'll become with the process. All right, the next one is very similar. It says write the equation of a circle whose center has coordinates 0, -2, and whose radius is of length 9. So once again, I'm simply going to plug into my formula x minus 0, quantity squared, plus y subtract -2, quantity squared, equals 9 squared. And again, I'm going to clean this up and tidy this up and neaten this up just a little bit. X minus 0, if I think about or consider what's in the first set of parentheses. Well, anything minus 0 is just that same number I started out with. So x subtract 0 is x. We need to square it. Subtracting a -2 is kind of a messy way of saying adding 2. So I'm going to change my subtract -2 to a +2. And then is equal to the square of 9, which is 81. And again, we put a box around it and call it done. The next one is kind of an interesting little example because this time they give us a radius where the length is written in radical form. The process, folks, isn't going to change at all. It's going to be exactly the same. I'm going to start out by doing x subtract my negative 7 plus y subtract my 0. Oh, and I need to square both of those. I got distracted by my line that suddenly appeared there. Is equal to the radius 2 radical 5 squared. And again, now I'm going to go in and I'm going to do my cleanup. X subtract a negative 7 is the same as x plus 7. Y subtract 0 is the same as y. And then on the right-hand side over here is where the fun really gets started. 2 radical 5 quantity squared. Well, remember that to square a number means to multiply it times itself. So this really means 2 radical 5 times 2 radical 5. I'm going to go in here and I'm going to multiply my two coefficients and get 4. When I multiply my two radicals, I get radical 25. But 25 is a perfect square, and its square root is equal to 5. So that gives me 20 for the square of the radius. Now I did a little bit of algebra over here to find that. If you don't trust your algebra skills, dig your calculator out of your backpack, and you can go in and you can type into your calculator 2 root 5 quantity squared. The only piece of caution or cautionary advice I'm going to give you on this is that if you're going to use your calculator to do this, you need to make sure that you put the number that you're squaring, in other words the 2 root 5, inside parentheses. If you don't put that inside parentheses, what this will do is it will square the square root of 5 first and then multiply that number times 2. And that's not what we're trying to do here. We want to actually square the entire phrase 2 square roots of 5. So again, if you don't trust your algebra, trust your calculator. All right, at this point, I'm going to stop talking for 30 seconds or so that you can go write your equation for letter D. Now, hopefully you've got something down on your paper. If you do, great. If you don't, commit to something, anything. We'll check it when you come back to class the next time and see how correct you in fact were. In the meantime, I'm going to boogie on to the bottom of that page where it's asking us to complete the empty spaces in the chart below. And this is just translating back and forth between center radius and what the equation might be. In this first example, they're asking me to work backwards, and they're asking me to use this equation in order to make the determination about what the center is and what the radius is. Well, since I'm doing an x minus 6, I know that the x part of my coordinate for the center has to be a 6. And because the second part of this does a y plus 7, I'm going to think about that as a y subtract negative 7. And I know that the y part of my coordinate for the center of the circle has to be negative 7. I also know that they got this number over here by taking the length of the radius and squaring it. So to go backwards and determine the length of the radius, I'm simply going to take the square root of that number, making my radius 5. All right, in the second line of this chart, we're simply doing the same thing that we were doing up at the top of the page. X minus 8, quantity squared, plus y plus 4, the whole thing squared, equals the radius squared, so equals 4. Third line in the chart, we're doing exactly what we did in the first line. We're using the equation of the circle in order to determine the center and the radius. So because this is a plus 9 here, I know that the x part of my center is a negative 9. A plus 4 here tells me that the y part is going to be a minus 4. And this number over here, remember, represents the square of our radius. So if we want to determine the radius, we're going to have to undo squaring it, or in other words, take its square root. I am, of course, never going to leave a perfect square factor underneath the square root. The largest perfect square that'll go into 32 is 16. Square root of 16 becomes a 4. Square root of 2 I can't do, so I'm just going to leave it. So the length of my radius in simplest radical form is thus 4 roots of 2. All right, I am again going to pause for a minute and let you go out down to the bottom and do the last 2 lines in that chart. And again, we'll check your answers the next time you come back to class. At this point, hopefully you're starting to become a little bit more comfortable with and familiar with this whole process of using the center and the radius in order to write an equation. Because up at the top of the next page, we're going to kick it up to the next level, and we're going to use the equation to go ahead and draw the graph. So it says, sketch the circle whose equation is given. Before we can sketch the circle, we need first of all to determine the location of its center and the length of its radius. Well, from this equation, I can determine that the center has coordinates 5, -2, and that the length of its radius is 4. So in order to sketch his graph, the first thing that I'm going to do is I'm going to go locate the center of the circle on the graph, and then plot that point. And I know that my circle contains all the points that are at a distance of 4 units away from that center. So I'm going to go find some points that are 4 units away from that fella. And then I'm simply going to be very neat and as precise as I can be without using a compass. I'm going to sketch my circle. Sometime in the next week or week and a half, we're going to learn how to use a compass, and then you'll be able to draw your circle a little bit nicer. But for now, the sketch will suffice. All right, moving onwards to letter B. Again, what we're going to do is use the graph to sketch the circle. So before we can sketch it, we need to know where to put it. So the first thing we're going to do is determine the location of its center. And once we know where its center is, we also need to know its radius so that we can graph it. So I'm going to start by going and putting that center down on my paper. And then I know that every point on the circle has to be exactly 5 units away from that center point. So I'm going to go find a few of those. And now that I have a pretty good idea of where my circle is going to go, I'll grab my pen and I'll sketch my circle. And again, not the best looking circle, but for right now, it gets the job done. All right, you made it through to the last example for this video. It says, solve the following system of equations graphically. Now, you're no strangers to solving systems of equations graphically. Remember that to solve a system of equations graphically means put them both on the same coordinate axes and find the point or the points where they intersect. So the first thing that I'm going to do is I'm going to graph these 2 equations. I'm going to start with this first one. This first one is in that form that was familiar or introduced to us today. We know by looking at it that it's going to be a circle. We also know by looking at it that its center has coordinates 2, -3. And then its radius has a length of 2. So I'm going to go ahead and get that circle graphed. And anytime you put more than one graph on the same set of coordinate axes, you need to make sure that you label the graph. So I'm going to go ahead and label this guy with his equation. His equation is bigger than he is. And then I'm going to move on to the second equation. The second equation in my system says x minus y is equal to 3. That is not the equation of a circle. It doesn't fit the pattern that we looked at today. You should recognize this as the equation of a line. And to graph a line, I can do one of two things. I can either graph it by examining its slope and its y-intercept, or I can graph it by putting a table or creating a table of values in my calculator. Regardless of which method you pick, the first thing you need to do is to isolate the y. So I'm going to isolate the y by first of all subtracting an x from both sides. Keep in mind that this term here is a subtract y, so when I bring it down, I have to bring down the minus y. And that's going to be either equal to 3 subtract x or minus x plus 3. I don't want to solve for a minus y, I want to solve for a plus y. So I'm going to go ahead and take the opposite of each one of these terms. And now I'm at a point where I can either put that into my graphing calculator, or if I'd prefer, I can graph using slope and y-intercept. I'm going to graph using slope and y-intercept because I think it's a bit quicker. So this guy's going to bump into the x-axis, or sorry, the y-axis at -3. So there's -3 on my y-axis. Slope is rise over run, so up 1 over 1. I need to move in a positive direction because my slope is a positive number. And because I'm solving a system, I'm going to be a little exact about how I draw this line. I don't want a sloppy line. I want a nice, neat, exact line. And as you're doing these in class, you're going to want to make sure you use a ruler to get a perfect line. And like the circle, I'm going to label this guy with his equation. Now the whole point of doing this and putting them on the same set of coordinate axes was so that I could figure out at what points the two intersected, or what points the two had in common. So they intersect in two places where both of those pink dots are. Those two locations are going to be the solution to our system of equations. So they intersect at the point whose coordinates are 2, -1. That's one solution. They also intersect at that point whose coordinates are 0, -3. That is a second solution. So this is kind of a cool system in that, like some of the quadratic linear systems we looked at, he has two solutions. Now some of these systems will have two solutions, some will have one solution, some will have 0 solutions, but all of them will fall into one of those three categories. Either they won't have any points in common, they'll have 1 point in common, or 2 points in common. All right, so the next time you come back to class, we'll do some practice on some of this coordinate geometry. If you do have questions after watching the video, now would be a good time to make a note in the margin so that you'll remember to ask me your questions the next time you come back to class.